Okay, so we are going to be looking at operations with radicals. So this will be adding, subtracting, multiplying, and dividing. At this point, we've done a couple different days on simplifying radicals, so we'll still be using that, but then we're going to be kind of adding a second layer to it. So before we get started, we're going to just talk about how we add radicals and what we cannot have, for example. So our first thing that we are going to say is you can only add radicals that have the same value. And we'll kind of talk about what this looks like with a few examples. And then I'm just going to say you may need to simplify first. Okay, so for example, if we have root 2 plus root 2, we can add those because they're both root 2's. So when we ask how many root 2's do we have 1 root 2 plus 1 root 2, which would be 2 root 2. Now, root 2 plus root 2 is not root 4. Okay, so that's important to know. And then if we have root 2 plus root 3, this would be not possible. We cannot add these because they don't have the same term. So think of it like terms, right? We can't do 3x plus 3y, but we could do 3x plus 3y, okay? So if we're trying to add apples and oranges, we couldn't do that. So they have to have the same variable, or in this case, number under the radical. So we're going to go ahead and look at a few examples now. Once you know that, now the math is really easy, right? So we have 3 root 5 minus 7 root 5. So this works because they're both root 5. So if I have 3 root 5's and I take away 7 root 5's, I now have negative 4 root 5. And that's it. If I have 6 root 6 and I subtract 5 root 6, I would have 1 root 6, or I could just leave it as root 6. This one I have root 3 minus 3 root 3, so I'm going to go ahead and put a 1 here just because it's kind of easier to see what we're subtracting. So I have 1 root 3 minus 3 root 3, which would be negative 2 root 3. Okay, this is where we get a little tricky. So these are obviously not the same. So some of us might automatically say, oh, we can't do it because they're not the same. However, like I did in the red bullet point, I said you may need to simplify first. So what we want to do is simplify the root 27 to see, well, maybe it is, or maybe it does have a root 3. So I'm going to go ahead and do that over here. So 27 is 3 times 9. 3 times 3. So we have that pair of 3's, and then we have a lonely 3. So technically, root 27 simplifies to 3 root 3. So on this side, I have 3 root 3. Then I have minus 2 times 3 root 3, because 27 is 3 root 3. So this would be 3 root 3 minus 6 root 3. Now these are exactly the same, right? So we can now subtract them. So if I have 3 root 3's and I take away 6 root 3's, I'd have negative 3 root 3. Okay, so let's go ahead and look at our next example. So once again, we're kind of stuck here, right? These are not the same, but maybe we can make them the same. So let's go ahead and branch root 8. So this would be 2, 4, and 2, 2. So we have a pair of 2's, and then we have a lonely 2 by itself. So this would be negative 2 root 2 plus 2 root 2. So in this case, if we have negative 2 root 2 plus 2 root 2, it's just 0. Okay? And then lastly, our last addition problem, or subtraction rather, same thing, is this one. So once again, we're kind of stuck. We can't add them, but we want to see if we can simplify. Now, root 6, I cannot simplify, but maybe I can simplify root 24, so it has a root 6. So this would be 2 times 12, and 2 times 6, and 2 times 3. So we would have a pair of 2's, and then a 2 and a 3. So we would have negative 13 root 6, and then we have plus 4, and instead of root 24, I'm going to write 2 root 6. So then this would become negative 13 root 6 plus 8 root 6, and we can now combine those. So you're really doing negative 13 plus 8, which would be negative 5, and then we have root 6. All right, so that was addition and subtraction. So the main takeaway is that it has to be the exact same root in order to add them. If it is not, then you need to see if you can simplify it, and then from there add them. Now, once you simplify, if they're still not the same, then that's where you would say not possible. Okay. Moving along to multiplication. So our first little bullet point here is just kind of like an example, kind of like almost like our properties that we did. So if I have the square root of A times the square root of B, what that really means is the square root of AB. So the great thing, just like when we think about fractions, when we add and subtract fractions, it's kind of annoying because you have to have a common denominator. When you multiply fractions or divide them, you don't, right? You just go straight across. So it's similar in a way. When we add or subtract radicals, they have to have the same radical. But when you multiply or divide them, they don't. You can just multiply them, okay? So we have root 2 times root 3. They don't need to be the same. We just multiply and we get root 6. Now you can simplify after. So like, can I simplify root 6? I would just get 2 times 3, right? And we want to find, you're trying to see if there's non-prime numbers. So that one would be done. Root 4 times root 9 would be root 36. Now, can I simplify that? Well, root 36 is 6. Another way you could have done this is simplify before you multiply. So root 4 is 2 and root 9 is 3. So 2 times 3 would be 6, right? So either way is fine. Now, another thing, I'm going to kind of do another bullet point here, is if I have root A times root A, this would actually just be A. So that means if you have a radical and you multiply by itself, you end up getting what's inside. So a few quick examples to show this. If I have root 15 times root 15, I just get 15. Think of it with like smaller numbers, right? If we have root 5 times root 5, you would get root 25, and root 25 is 5. Okay, if I have root 4091 times root 4091, I just get 4091. Okay, now these are different, so we'll have to do a little bit more work, but I have root 25 times 2, so this would be root 50. Now, can I simplify that? I'm going to do that over here. Let's see if we can. So we would get 2 and 25, and then 5 and 5. So we have our pair of 5s, and then we have a lonely 2. So this ends up actually being 5 root 2. Now, some of you might be asking, well, couldn't I have simplified before? Absolutely. Root 25 is 5. So you could have thought of this as 5 times root 2, which is 5 root 2. Okay, now we're getting a little more complicated, right? Because now we have some variables. So we're going to still multiply them straight across. So, and then we'll deal with it after. So 6 times 3 is 18. We have x squared and x, so think of this as x to the first power. So x squared and x to the first would be x cubed. We have y and y cubed, so think of this as y to the first and y cubed, which would be y to the fourth. So the first thing we want to do is deal with that 18. So this will split to 2 times 9. 9's not prime, so we have to keep going. 3 times 3, and then those are prime. So we get stuck. So this would be 3, and then root 2 would be left inside. Okay, now we're kind of going back to simplifying radicals. So when we have x cubed, we want to think how many x squareds are there? There's 1, but 1 left over. And then for y to the fourth, how many y squareds are there? There's 2 and none left over. So that would actually be our final answer. Okay, and our last multiplying one here, we're going to do the same. So 3 times 9 is 27. And then, so this would all be, under the radical. Then x cubed times x to the first would be x to the fourth. Y to the first times y to the fifth would be y to the sixth. So first we'll deal with 27. This would be 3 times 9 and 3 times 3. And then we're kind of stuck with all prime numbers. So this turns into 3. And then on the inside would be root 3. And then how many x squareds are in x to the fourth? 2. How many y squareds are in y to the sixth? 3. So then that would be our answer. So 3x squared y cubed root 3. Okay, lastly, division. So this is actually probably the most difficult one, just because we can't have a radical in the denominator. So that is going to be kind of the first thing that we say. So can't have a radical in denominator. So kind of just, this is like another math rule, right? We can't have negative exponents, so we can't have a radical in the denominator. So if we do, then we have to do something called rationalize it, which we're going to learn. It sounds more complicated than it is. So if you have root A over root B, you can also think of that as root A over B. So both of these mean the same thing. So let's go ahead and look at a few examples. So the first thing that you should do when you have these is ask yourself, well, can I do 9 divided by 49? Absolutely not. So then you want to separate them, right? Think of this as root 9 over root 49. Well, what is the square root of 9? It's 3. What's the square root of 49? It's 7. So then we would be done. Easy. Next one. Can I do 1 divided by 4? Not easily. So then I'm going to have the square root of 1 over the square root of 4. So the square root of 1 is 1. The square root of 4 is 2. So my answer would be 1/2. All right, looking at the next one. Can I do 18 divided by 2? Yes. So 18 divided by 2 is 9, right? But it still has to have that radical. Then the square root of 9 is 3. So that would be the answer. On this one, can I do 18 divided by 3? Yes, we would have 6. Now, can I branch that? Well, I would just have 2 and 3, which are both prime numbers, so we're kind of stuck. So that would mean we're done there. Okay, can I do 2 divided by 3? Nope. So let's go ahead and separate them. So this would be root 2 over root 3. Now, can I take the square root of these? No. So this is where we're kind of stuck because we can't have a radical in the denominator. So what we do is we actually multiply both the top and the bottom by whatever is in the denominator. So then we have root 2 times root 3, which is root 6. And we learned today that root 3 times root 3 will just be 3, right? Root anything times itself is just itself without the root. And then this is the final answer. I can't divide these. I cannot make it root 2 because they're not like terms. So you would just leave it like this. So let's try a couple more examples like that because it's a little crazy. So on this one, let's go ahead and simplify what we can first. So I can't divide them, but I do know that the square root of 4 is 2, right? And then I have the square root of 27. Now I can simplify that first if I want, but I'm going to go ahead and just multiply both the top and the bottom by root 27, okay? Because I want to get rid of that root in the denominator. So on the top, I would have 2 root 27, and on the bottom, I would have 27. Now, 2 and 27 I can't simplify, but root 27 I can. So I'm going to go ahead and branch this. So this would be 3 times 9, and then 3 times 3. So you always want to simplify your radicals when you can. So then I would end up having 2 times 3 root 3 over 27. So then this becomes 6 root 3 over 27. So it gets even more complicated. Now we could actually reduce 6 and 27. They both have 3 in common. So this would become 2 root 3 over 9. So that one was a little bit tricky. We had a lot going on. All right, lastly, we have a negative in front. So that means I will have a negative in my answer. Now I can think of those as just separate. So the square root of 25 is 5, and the square root of 49 is 7. So I would definitely recommend rewatching this if you need to, because it was a lot of information.